Factors of a given number are numbers that have a product equal to the given number. Factors of a given expression are expressions that have a product equal to the given expression. Factoring is rewriting an expression as a product of its factors. To understand how to find the binomial factors of a quadratic trinomial, recall the process of multiplying two binomials to get a trinomial. You can use the distributive property or the FOIL method to multiply two binomials. First, the distributive property. If we multiply the binomials x plus 4 and x plus 2, we have x plus 4 times x plus x plus 4 times 2. Distributing, that's x times x plus 4 times x plus x times 2 plus 4 times 2. Simplifying, that's x squared plus 6x plus 8. Or we can FOIL. The FOIL method, recall F for first, O for outer, I for inner, and L for last in terms of the terms of the binomials. Multiplying the first term, so that's x times x. The outer terms, x times 2. The inner terms, 4 times x. And the last terms, 4 times 2. Simplifying, that's x squared plus 6x plus 8. You can use FOIL in reverse order to help you factor. To factor x squared plus 6x plus 8, find two binomials for which the first terms have the product x squared. The products of the outer and inner terms have the sum of 6x, and the last terms have the product 8. X squared plus 6x plus 8, well, x times x is x squared, so our first terms can be x in both cases. And factors of 8, well, 4 and 2 are factors of 8. 4 times 2 is 8. So we can rewrite this trinomial as the product of its binomial factors, x plus 4 times x plus 2. When you factor, a table of the different possible factors of the constant term may be helpful. Problem 1. Factoring ax squared plus bx plus c when a equals plus or minus 1. What is the expression in factored form? Part A, x squared plus 9x plus 20. Well, in step 1, we'll find the factors of 20, our constant term, with a sum of 9, the coefficient of our linear term, 9x. Since both 20 and 9 are positive, both factors are positive. The factors of 20, 1 and 20, 2 and 10, and 4 and 5. The sum of these factors, 1 plus 20 is 21, 2 plus 10 is 12, and 4 plus 5 is 9. So take note, the factors of 20, 4 and 5, when multiplied equal 20, and the sum of those factors is 9. Note that's our coefficient of the linear term, 9x. Step 2. Use the factors you found. Write the expression as the product of two binomials. So we can write that x squared plus 9x plus 20, our original trinomial, equals x plus 4, note the 4 being a factor of 20, times x plus 5, the other factor of 20. Part B. How about the trinomial x squared plus 14x minus 72? Step 1. We need to find the factors of negative 72 with a sum of 14. Since c, our constant, negative 72, is less than 0, one factor is positive and the other is negative. Note that a positive times a positive is a positive, and a negative times a negative is a positive. So for us to achieve a negative here, one of our factors must be positive, the other must be negative. Since b, our coefficient of the linear term, for us that's 14, is greater than 0, the factor with the greater absolute value is positive. So, considering a table with our factors of negative 72, negative 1 and 72, negative 2 and 36, negative 3 and 24, negative 4 and 18, negative 6 and 12, and negative 8 and 9. And then the sums of those factors below, we find that for negative 4, 18, we have a sum of 14. So those are the factors we want to use. In step 2, use the factors you found, negative 4 and 18. So we write the trinomial, x squared plus 14x minus 72, as the product of its binomial factors, x minus 4 and x plus 18. And again, we can check by foiling. x times x is x squared, great, plus 18x minus 4x, combining those like terms, that's plus 14x, and a negative 4 times a positive 18 is negative 72. Our solution checks out. Part C, how about the trinomial negative x squared plus 13x minus 12? Step 1, rewrite the expression to show a trinomial with a leading coefficient of positive 1. So we'll factor out a negative 1. Take note, the negative is on the outside of the parentheses, and our negative x squared, having factored out a negative 1, is simply x squared, or positive x squared. What used to be a plus 13x, having a negative 1 factored out, is now a minus 13x. And what used to be a minus 12 is now a plus 12, having factored out negative 1. Step 2, we'll find the factors of 12 that have a sum of negative 13. Since c, our constant, positive 12 in our trinomial that has the negative 1 factored out, so looking inside the parentheses, but since that's greater than 0, both factors have the same sign, so they're either both positive or both negative. Since b, negative 13 in our factored form, is less than 0, both factors must be negative. So we can create a table showing the factors of 12, and then we're seeking the factors that have a sum of negative 13, and that's negative 1 and negative 12. So in step 3, we'll use the factors we found, negative 1 and negative 12, to write that the trinomial, negative x squared plus 13x minus 12, equals the negative of the trinomial x squared minus 13x plus 12, which equals the negative, note the negative just hangs out there on the left, but the negative of the binomial x minus 1 times the binomial x minus 12. Your turn, part A. What is the expression x squared plus 14x plus 40 in factored form? Part B. What is the expression x squared minus 11x plus 30 in factored form? Part C. What is the expression negative x squared plus 14x plus 32 in factored form?